In the words of Albus Dumbledore,
It is not our abilities that show what we truly are. It is our choices.
Math is about making choices. Some choices lead to frustration, others to glory. In math, you can make the wrong choice and still get home, but it may take a while. We learn from our choices. Some choices make things easier, some make them more complicated, but we can always learn from our choices and discover that the next time around, we'll be better equipped to make things go the way we want. So ironically, it is often by limiting our choices that we best succeed. When we force ourselves into the best choices by recognizing the choices that lead down the rabbit hole. So let's talk about the rabbit hole. The rabbit hole is where the ramifications of an unthought out choice are hidden from view. You turn right instead of left. Things look familiar, but they're not. You make another turn, and another, and another, and before you know it, you're completely lost. If only you'd taken a few moments over that first choice. To illustrate this, let's look at a fun little puzzle I call Surrounding the Stars. Here we have a little game board filled with red stars, blue stars, and numbers from 1 to 8. The challenge is to surround each red star with all 8 numbers with no repeats. Some of the numbers have already been filled in for us, which might make our task appear deceptively simple. So where do we start? Does it matter? Probably. Some stars have as many as 4 open spaces. Others have less. At first glance, having 4 choices might seem nice. This middle star has 4 open spaces. The 3, 4, 5, and 7 have been placed for us. We get to choose where to put the 1, 2, 6, and 8. Does it matter which number we place first? We'll see. For now, let's try the 1. We could put it up top, or bottom left, bottom middle, or bottom right. One looks as good as another, except for bottom left. If we put our 1 there, it will interfere with this star on the right. It already has a 1 around it, and can't support another. The top square is okay. This one won't interfere. Bottom left looks good, and so does the middle. Here's where we're tempted to make a guess and hope for the best. What if we put the 1 bottom middle? Let's see what happens. Next up is our 2. Can't place it bottom left or right. These stars already have 2's. Top middle looks good, and the 6. Both remaining choices look fine. Let's drop it bottom right, which forces our 8 to go bottom left. This leaves only 1 open square around the bottom star. We can put a 3 there, and that left star has only 1 open square, so a 1 looks good there. Or does it? No, we already have a 1 up top, but where does that leave us? We'll have to vacate the 6. But then we'll have 2 1s around the middle star, which means we'll have to vacate the 1, but where to put it? And that 3 down there, I'm not sure about that. These are getting messy. Could we have avoided the mess? And how did we get in this mess after all? The rabbit hole. Let's start again. What if we focus on this star to the right? How does this affect our choices? Only 2 open squares. The 1, 2, 4, 5, 7, and 8 have been chosen for us. Even if we guess, we now have a 50% chance of being correct. But let's not guess. Let's look at this square on the right. 3 or 6. Which do you like? Well, there's a 6 right there. Putting another 6 right next to it doesn't seem right. Well, why not? It won't affect our chosen star. But what about the star above? We don't want to give it 2 6s, which means we have only one choice, the 3. We have to put the 3 in this square. We have no other choice. And that's what's called the forced choice. What happens from here? We weren't allowed to put our 6 here, so it has to go here. The top star now has only one open space, and the only missing number is the 4. That seemed deceptively simple. And yet, is there any doubt that all our choices have been correct? No, not at all. We were forced in each case. Let's keep going. Should we move back to the middle? No, there are still too many open squares around it. Let's look at the top left star. What have we got here? We're missing a 2 and a 6. I don't see any 6s in the area, but there is a 2 down there. If we put a 2 in here, this star will have 2 of them, and that's a no-no. So we're forced to put in the 6. Feels strangely nice being forced. With the 6 there, we're now forced to put the 2 up top. Forcing that 6 has also left us with just one open square around this star. Our only option is the 1. And now we're ready to move back to the middle. Both stars have just 2 open squares. Before we fill them, notice that when we fill any one of them, we will be forcing the others. Filling this top one forces the middle one, which in turn forces the bottom one. Conversely, filling the bottom square forces the middle square, which forces the top one. And filling the middle square forces both the others at once. Well, that sounds fun and rather efficient. Looking at the top star, we have both the 2 and the 8 available. But there's an 8 here around the bottom star, so we're forced to use the 2. And now everything falls, or is forced, into place. We're forced to use the 8 up top. There's a 2 missing down here that we're forced to put in. And we're done. Looking back on it, we employed a very simple strategy, which worked to perfection. Now, what was this strategy? First, find a star that has the least blank squares around it, the least choices. Second, determine which numbers are available to fill those squares. Third, look for a way to disqualify a number from consideration for a particular square. Importantly, we're not focusing on where a particular number should go. Instead, we're ruling out every other number. When there's only one number left standing, recognize that we are forced to put it into the square. Lather, rinse, repeat. What would Professor Dumbledore say about how we solved the puzzle? It wasn't through any great mysterious ability. It was the choices we made. In our next video, we'll do a little more complicated version of forced choices in the game of high-stakes tic-tac-toe.